Moreover, remember that we only want to have this only mode in the port 1. So just to make sure, we got to make sure actually that TM11 is not propagating at this port. And how do we do that? Well, if you remember, E7 corresponds to the second TN mode, and the second TM mode, okay, the second TM mode, as we said before, is actually TM11, and we don't want to have this mode excited here in the at this port. So for that, check the cutoff frequency of our TM11 mode. And which is the cutoff frequency? Actually, as you can see, it is 36.5 gigahertz, which is quite higher than our 21 gigahertz. So with that, we guarantee that we don't have TM11 propagation at this port, because the cutoff frequency is quite higher than our frequency band. And regarding the transmission port, in other words, port 2, what we want here is to have both modes, to have TE11 plus TM11. So we had to look for the first TE mode and also the second TN mode. Okay? As we said, we move to port 2, and if we select E1, this is the TE11, and E7 is the TM11. Okay? So we got to check their cutoff frequency. Remember, this port 2 has a 31 gigahertz operation. Okay, I will show you. As you can see, yeah, the transmission is at 31 gigahertz. Okay, so TE11 has a cutoff frequency of 11, also almost 12 gigahertz, which guarantee that this mode is propagated. Remember, you got to have a cutoff frequency below your operation frequency band. Okay, and then if we move to E7 and look for the cutoff frequency of our TM11, is more or less 24.1. As we said, it is below, just a bit below our 31 gigahertz operations, which guaranteed that this mode will be excited at port 2. Okay, so at port 2 we got excited both modes, actually modes that we want to have. Okay, so that's the reading. That is how you read all those CST results. Okay. Okay, so once you have done this study regarding port mode, remember 2D port modes propagation. Okay, once you get the dimension, okay, you got to play with all those parametrics in order to accomplish your cutoff frequency. Okay, as we explained before. So changing the diameter here and here, you will change your cutoff frequency of each port. Okay. Which more? Okay, so once you have done this, it's time to validate your design, and it's time to adapt and to match your antenna perfectly. And how do you do that? Well, basically, now you simulate the whole thing without this checked box. Okay, so uncheck it and select all ports. Okay, and what you gonna get? You're gonna get a typical simulation with your S11 result, all your ports, mode propagation, and also your far field and everything. Just a typical simulation, and that is the second step that we need to do in order to optimize your horn. So first of all, you optimize it using just port modes simulation, and then you optimize. And remember, for that you need to configure each port for 8 at least ports. Okay, but now on this second step we can just select one port. Okay, we can just select one port because we are sure that our dimensions accomplish those cutoff frequency. And for the second port is the same. Okay, port 1 and port 2. Okay, so now we just want to simulate without, like this. Okay, like this port. Okay, and accuracy 13. We are what you will see now, and we will comment all the results. Okay, so let's run it. Starting, blah 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 blah. Okay, guys, so once your simulation finished, what you get is this. The most important is to look for your 1D result, and look what we got here. Remember, the simulation was this one. We got our port 1, our port 2, and we defined just one port to simulate. Okay, just one number of modes, one number of modes on each port. And what do we get? Well, we get the typical result: 1D, 2D, far fields, template, if you define it. So regarding the matching of your horn antenna, we should look this one. What do we have here? Look at this, look at this. What do we got? Here I launch a parametric sweep, okay, for the optimization of the aperture radius, okay, between this value and this value, step and linear sweep. Okay, and this is what we get. So first of all, we check the S11. What do we need to validate this result? Well, basically what we need here is to get an S11 below minus 10 dB, as we said in previous video. For example, look at the value minus 10 dBs here at 21 gigahertz dot 7.5, or maybe like this. So results. As you can see here, all those parameters, all those results are quite good for us. Okay, as you can see in this frequency band, the matching of our horn antenna is quite good, which means that we are ready to excite, we are ready to use our horn at 21.5 for receiving, okay, for receiving, which was the requirement. Okay, so look at this. For example, I will go for this one, just one, okay, just to make it easier. Look the matching that we got here. For example, at 21 and 7 gigahertz, we are around minus 21, almost minus 22 dB matching, which is great for our application. Okay, this is regarding port 1. So let's move to port 2. We got to look for the S22. Remember, S22 and S11 are the matching of your port, and S21 and S12 are the others as parameters regarding transmission. Okay, regarding transmission, but we are not looking for that. We are looking for the matching of our ports. So for that, we have to check S11 and S22. So regarding S22, remember the frequency, the operation frequency that we need to optimize was 31 gigahertz. So we move that to that point, 31. Okay, and as you can see here, I will show you this simulation is run. Don't look at it, don't select it. So if we increase the radius of our aperture, look the effect. We are increasing, so if we make it bigger, the frequency is getting lower. Okay, because the relationship between lambdas and the frequency, you have an inversive relationship. So if we increase the cutoff, if we increase the antenna, the frequency gets lower. Okay, sorry, lower. So look at this. We keep increasing, and look where is now the null. Okay, this valley. So it moved from here to there. And which one do we need? Well, the best. And which one is the best? The best is where we move the value, the null, the minimum value, okay, to our frequency range or to our operation frequency. So for 31 gigahertz, it would be awesome to get this S22 match. Okay, matching. So we will define, this is the optimization process, so we will use the aperture radio value as 7.6 millimeters. So as you can see, it's the best. It actually match with what we are looking for. Okay.